Hey everyone, we are Group 3, and my group and I will be presenting about geotechnical engineering. But before that, I will be presenting a video for you right now where geotechnical engineering is not commonly known in many places.
D'après vous, qu'est-ce que c'est que la géotechnique?
C'est ah c'est la danse. Là, le truc où tout le monde dansait il y a quelques années.
Je ne sais pas.
Je sais pas. Géographie.
C'est un peu beauf. Enfin, c'est un peu comme la Macarena ou tout ça quoi.
C'est en lien avec la géographie.
C'est de la technique dans le monde.
Géo, je dirais, lié à tout ce qui est géographique et les techniques qui sont liées à l'environnement.
Le bâtiment, je suis complètement nul.
Et tout ce qui concerne les tremblements de terre, la construction des bâtiments pour résoudre les problèmes la géotechnique.
Oui, je n'avais pas pensé.
D'après moi, la géotechnique, d'abord, il y a le mot géo, il y a le mot technique dedans, donc c'est certainement la technique de la géologie, la résistance des matériaux qui composent la géologie.
Ça doit être l'étude des sols. Je suis pas sûre, mais...
On n'en parle pas souvent. Ça n'a pas un aspect très sexy comme ça, avec des grosses machines, ouais, voilà, de la poussière, des grosses installations, ça fait beaucoup de bruit. Ça fait plus bourrin en fait.
Que les engins soient là et qu'ils creusent et que finalement ils se retrouvent au fond du trou, c'est normal, mais comment est-ce qu'on les remonte?
C'est un domaine que je connais pas du tout parce que la physique-chimie, j'ai arrêté depuis un petit moment.
Lorsque vous faites un grand bâtiment, il faut des fondations qui soient adéquates.
Antisismique.
Oui, et puis adéquates par rapport à la taille du bâtiment, etc.
J'admire la grandiosité et l'esthétisme des œuvres parce que souvent les architectes arrivent brillamment à associer les deux, mais c'est vrai que je vois que le côté immergé de l'iceberg et non pas tout l'iceberg et tout le travail qui a pu être fait pour construire ce type d'œuvre.
Les questions qu'on se pose, c'est est-ce que ça va tenir?
As you can see from the survey, only few people have an idea of what geotechnical engineering is. One reason why geotechnical engineering is not well known because they are only present before the building phase of a building, checking the soil quality and doing the research for suggestions on what to improve. Even though they are not well known, they are the most important branch to ensure the safety of the people when the building is built. That's why we are presenting in order for us to enlighten you with the different uses and importance in the field of geotechnics. My members will be explaining different information later, like the job responsibilities, the difference of a geologist and a geotechnical engineering, history, importance, soil properties that they study, and many more. But before all that, we will be watching a video on geotechnical engineering to head start our learning on this field.
Geotechnical engineering is the story of the engineering relationship between humans and Earth. It is the science that explains the mechanics of soils and rocks and its engineering applications to the development of humankind. In early times, the practice of geotechnical engineering was applied by trial and error, observational experience, and empirical experimentation. Problems such as the notorious Leaning Tower of Pisa prompted engineers to begin taking a more scientifically based approach to geotechnical engineering. From the early 1700s to the early 1900s, scientists such as Coulomb, Darcy, Rainkin, Bassanesque, Moore, and Atterberg published fundamental theories on soil mechanics and water flow through soil. Several prominent organizations and societies were formed in the early 1900s to advance this field of civil engineering. Particular recognition is given to Karl Terzaghi, who is considered to be the father of modern geotechnics with his classic book on soil mechanics published in 1925.
In 1936, along with fellow colleagues from 20 different countries, Terzaghi founded the International Society for Soil Mechanics and Geotechnical Engineering. He became its first president. Today, the International Society has more than 89 country members involving over 19,000 individuals in the geotechnical engineering profession.
Most of what geotechnical engineers do is hidden below the ground surface, yet it is a very important discipline with a vast scope, as all construction has to rest on or in the ground. Soil is a complex material, which is very variable in grain size, cementation, strength, and behavior. This renders the task of the geotechnical engineer among the most challenging tasks in civil engineering. Geotechnical engineers use fundamental principles of soil and rock mechanics to investigate subsurface conditions. This allows them to evaluate and design activities such as the stability of natural slopes and man-made soil deposits, earthworks with cuts and fills, shallow and deep foundations, dams, retaining walls, tunnels, and many other works directly interacting with the subsoil and water.
In order to meet the diversity of challenges the profession faces, the International Society has created 30 technical committees over the last 50 years, each representing a particular aspect of geotechnical engineering.
Foundation engineering is one important area of geotechnical engineering. The foundation of any structure should be designed to withstand man-made and natural loads, vertical and lateral pressures created by earthquakes and high winds, as well as the weight of the structure itself. Buildings, skyscrapers, bridges, and other superstructures have to bear on shallow footings, mats, or pile foundations. Shoring systems include bracing of deep excavations, nailing of landslides, and the support of tunnels, to name a few. Any geotechnical engineering project is different. Indeed, the soil at a site is likely different from any other site. As a result, the most common first step of any geotechnical project is the site investigation. It starts by drilling into the soil and rock layers, testing them in the field or collecting samples, which can then be analyzed in a laboratory. Once soil and rock properties are determined, the geotechnical engineer can design the project, including its environmental impact. Investigations can include the assessment of the risk to humans, property, and the environment from natural hazards such as earthquakes, landslides, sinkholes, soil liquefaction, debris flows, and rockfalls. Geotechnical engineering can significantly influence the sustainability of infrastructure development because of its early position in the construction process. Given the intensive research carried out in the field, impressive geotechnical advancements are made on a regular basis. Most of these innovations are often hidden from the public eye because the work is underground. These innovations are, however, a crucial part of a success story. They can be temporary in nature, such as deep excavation support to construct a high-rise tower like the Burj Khalifa, or permanently embedded, such as the complex foundation system of the Rian and Tahran Bridge. The built environment where we live serves as a dynamic interface through which humans and the ecosystem interact and influence each other. Understanding this interdependence is key to fathoming the impact of geotechnical engineering on society.
Throughout history, geotechnical engineering has made changes in the way we live or even think. Projects like building the Aswan Dam, laying the foundation of the Golden Gate Bridge, digging the Panama Canal, stabilizing the cliffs at Pointe du Hoc, or giving new life to the Tower of Pisa have affected past and present generations. Such projects, large and small, will continue to impact and shape our future. It has been a cycle of sharing knowledge and gaining knowledge, of accomplishments and lessons learned. The International Society for Soil Mechanics and Geotechnical Engineering is proud to be at the center of this field emblematic of human achievement.
What are the job responsibilities of a geotechnical engineer? Geotechnical engineers research and study soil to evaluate its suitability for foundations. They investigate and assess construction sites, conduct lab tests, create designs for structures, supervise construction, and write and present reports. They work on such projects as designing tunnels, roadways, retaining walls, and earth dams, as well as helping to create strategies for the cleanup and management of contaminated sites. Geotechnical engineers often work for consultancies. They are also responsible for supervising on site construction of structures. Work includes creating reports of pretesting, as well as ongoing assessments, assessing data from the field, finding ways to ensure foundations or slopes are stable, designing foundations, and overseeing work on a construction site. They ensure environmental soundness of operations throughout the projects. Working as a geotechnical engineer, you'll support design and construction by carrying out testing and analysis to assess risk to humans and the environment. Risk can arise from natural hazards such as landslides, sinkholes, rockfalls, and earthquakes. The list of geotechnical engineers' responsibilities and duties are as follows. They perform geotechnical analysis and study to assess construction site condition. They plan and conduct geotechnical exploration effectively. They perform field and environmental investigations for construction projects. They analyze geotechnical findings, perform appropriate calculations, and prepare data reports to manager. They develop proposals and determine cost and schedule for investigations. They provide direction to technical team and field inspection activities. They interact with customers and team members to complete the assigned project on time. They evaluate team performance and determine training needs to meet performance objectives. They perform basic office administration tasks when needed. They assist manager in design and evaluate of constructions. They develop design drawings and specifications for construction projects. They review and approve geotechnical designs developed by outside consultants, and they review construction design proposals and approve geotechnical aspects. Those are the job responsibilities of a geotechnical engineer.
So what are the differences between geotechnical engineering and geologists? Geologists study the land to determine whether it is stable enough to support the proposed project. They also study water patterns to determine if a particular site is prone to flooding, while geotechnical engineers are experts at what can happen to the land to make it hazardous or become a problem when trying to build something on it. They might look at how climate affects things such as landslides, earthquakes, or soil erosions. So, what is geologist? Geologists have a variety of functions that range from working as educators to geoscientists. These men and women spend time at geological sites, running tests and surveys, collecting samples, and performing ground assessments. They look at the relationship of humanity to the environment over centuries, and they study the area of the construction deep. Job responsibilities of geologists includes collaborating with other geoscientists or environmental students, investigating data and aerial photos for information, preparing analysis reports, and presenting findings to students, clients, or other experts.
The history of geotechnical engineering. The primitive of soil usage. The history of geotechnical engineering is long and quite interesting. Our ancestors in the olden days used soil for an extensive variety of activities from building and creation of construction materials to irrigation and flood control. However, the earliest applications were not very much advanced. It was simply related to flood control as well as irrigation, as exhibited by the traces of dikes, dams, and canals that have been discovered in some parts of the ancient Egypt, Greece, and other parts of the world dating back to not less than 2000 BCE. The perception of soil as an art rather than science. As these areas developed, construction of structures were supported by formalized foundation began. For instance, the people of Greece notably built pad footings as well as strip and rough foundation during this time. However, the science of soil design was still a non-existing phenomenon. Foundation-related engineering issues. By the 18th century, as civilization advanced further, numerous engineering problems related to building foundations began to emerge. The Leaning Tower of Pisa was a tourist attraction today. For example, presented a very unique challenge at that time. What happened in that tower had been constructed on a soft ground composed of mostly clay, fine sand, and shells without using enough stones to make a strong foundation. Due to heavy weight, without enough base support, the structure had no option but to sink a little bit into the earth. One side happened to go further deeper into the ground than the other, causing the tower to lean on one side. The Leaning Tower of Pisa actually makes an important part of the history of geotechnical engineering. The emergence of the principles of soil mechanics. The Leaning Tower experience is what prompted engineering to start taking a more specific approach to setting up foundations of buildings with respect to the soil design and structure. Significant soil theories guiding the construction of buildings foundation began to emerge. A French engineer by the name Henri Gautier recognized natural slope of different soils, an idea which later on developed into something known as soil angle of repose, and then more principles of soil mechanics came into existence.
So, what is the importance of geotechnical engineering? The studies of the geological material properties on a construction site are important to allow design and construction of stable structures that 1. Do not settle, 2. Deform or crack, and 3. Do not fall down due to a foundation failure.
So the question now is, how does one become a geotechnical engineer? First, one should earn a degree in engineering bachelor's degree that includes general education courses in English, social science, and the humanities, as well as courses in advanced mathematics, structural geology, and fluid mineralogy. One should also take courses in computer-aided design or CAD using advanced principle to create, analyze, and review designs. Second, one should obtain a PE license or professional engineer license. In any engineer that wishes to work on projects that may affect the safety of the public will need a PE license. Lastly, one must obtain a graduate degree, which is optional for advancement. If one wishes to work as a project manager or supervisor, it most likely necessary to have an advanced degree.
The distributions of soils in nature varies from location to location. Geotechnical properties of soils influence the stability of structures. Here are the soil properties that are being studied by geotechnical engineers. The first is specific weight or unit weight. It is the cumulative weight of the solid particles, water, and air of the unit volume of soil. The second is porosity. Ratio of the volume of voids it contains air, water, or other fluids in a soil to the total volume of the soil. Porosity is mathematically related to void ratio by N equals E over 1 plus E, where N is porosity and E is void ratio. Third is void ratio, the ratio of the volume of voids to the volume of solid particles in a soil mass. Void ratio is mathematically related to the porosity by E equals N over 1 minus N, where E is void ratio and N is porosity. Fourth is permeability. Permeability is a measure of the ability of water to flow through the soil. It is expressed in units of Darcy's, or D. The fifth is compressibility. It is the range of change of volumes with effective stress. So, for example, if the pores are filled with water, then the water must be squeezed out of the pores to allow volumetric compression of the soil. This process is called consolidation. Sixth is shear strength. It is the maximum shear stress that can be applied in a soil mass without causing shear failure. And the next is the Atterberg limits, where it includes liquid limit, plastic limit, and shrinkage limit. These indices are used for estimation of other engineering properties and for soil classification.
Geotechnical engineer salary in the Philippines: 410,912 average salary per year, 198 per hour average hourly, and 11,506 average bonus. This salary estimate has been updated to include data from the COVID-19 impact.
That is all, and thank you for listening on our discussion on geotechnical engineering.